Let's think about which true formula is what allows us to collect like terms. This is the distributive law. Sometimes people just go a little too much on autopilot, and while it's okay to skip the step that we're going to show, it's good to understand what the step is, right? So out of both of the terms, 7x to the fourth and 2x to the fourth, so there's a 7x to the fourth plus a 2x to the fourth. Factor out an x to the fourth, and you can write that what's in yellow either before or after the parentheses. I wrote it after just because the x to the fourths were written after the numbers. And inside parentheses, you'll have 7 plus 2. And that 7 plus 2 is going to simplify to 9, right? So this is really using the distributive law. Sorry for the typo. This should be a C. Well, yeah, this fine. It was a B. Uh, and then C, but C we're plugging into, right? It's using this formula, and generally we skip writing this 7 plus 2 quantity, then times x to the fourth, when going from 7x to the fourth plus 2x to the fourth directly to 9x to the fourth, right? So typically we just jump directly to this and call it collecting like terms, but we should know why this works. Right? Collecting like terms really comes from factoring, and factoring is just the distributive law in reverse. So here's another example. 4x to the second times y plus 5 times y. Factor out a y, and that y is, because factored out, it's written outside of a newly drawn set of parentheses. I'm saying newly drawn set of parentheses because the original expression did not have parentheses in it. Okay, and we'll have now 4x to the second plus 5 inside the parentheses. Hold on to this, put a star by this example in your notes. We're going to need to come back to this at the end of today's slides. Just one thing that you've perhaps heard about, but I want to just make sure to clarify, there's a difference between terms and factors. So terms are things that are separated by plus signs or minus signs, while factors are things that are separated by multiplication signs. Okay, that will come up a little later. So let's simplify this polynomial subtracted by another polynomial. So I've got the two terms here in different colors. Just to illustrate, terms are separated by plus or minus signs. And let's go through this then. I'd like to distribute this -1. This right here, it's a minus sign, but you could think of this as a -1. Distribute it to a positive 2x cubed, to a positive 6x, and to a -3. And when you do that, you'll have a negative 2x cubed, a negative 6x, and a positive 3. And then collect some like terms. I didn't show all that same work with collecting like terms. Now I just did it, right? 5x to the third minus 2x to the third is 3x to the third, and so on and so forth. Let's simplify this product. So we have x to the second plus 3x minus 1. That is being multiplied by 5x plus 2. And so here, to illustrate this terminology of factors, those are separated by multiplication signs. And so what's in yellow, what's in green, they are being multiplied together. Even if there's no multiplication sign, there's no symbol, multiplication signs are often not written. So the two things in yellow and green, those are the two factors. So here we apply an extended version of that FOIL property. So x cubed should be multiplied both by 5x and by 2. Then the middle term, 3x, should be multiplied both by 5x and by 2. And then a -1 ought to be multiplied both by 5x and by a positive 2. So all 6 terms are written out. And then we'll do a little simplifying of these and collect like terms. Okay, let's simplify the fraction 12a to the second b to the fourth plus 3a to the fifth b to the third minus 6a to the second b to the ninth, all divided by 15ab cubed. In the denominator, please note that the little a, that the variable a is not being cubed, right? So the cube, the third power, only affects the b variable, not a, because of the order of operations. By the way, as written, the numerator consists of terms, not factors, right? So because of the plus sign and the minus sign, you have 3 terms in the numerator. You don't have factors, so you can't cancel anything, at least not yet, right? So in a fraction, the only time you can get cancellations are if you have factors. Well, fortunately, factoring makes factors. It sounds funny, but factoring, that is the verb, makes factors, that is the noun. And so you can factor in the numerator you can factor out a 3a squared b cubed out of all three terms. And what's left in parentheses would be 4b plus a cubed minus 2b to the sixth. Then the point is we can cancel. I just wrote out the 3a squared b cubed a little differently. Just like, for instance, the b cubed is written out as bbb. And then I've highlighted in yellow, there are factors that are the same on top and bottom. Those can all cancel. And you're left with a times the quantity 4b plus a cubed minus 2b to the sixth, close parentheses, all divided by 5. There is actually another way to do this in case you prefer. The pesky thing about this question was that we can't cancel right away because these plus and minus signs, or the plus sign and the minus sign, are in the numerator of the fraction. And so when you have that, you don't have factors, but you could actually apply the fraction addition and subtraction rules in reverse. And so the expression up in the question is actually equal to this, as answer 2 starts, 3 separate fractions, right? First fraction plus second fraction minus third fraction. This may seem peculiar, but think about doing this in reverse. If you had these 3 fractions, noting that they have a common denominator, you could squish this all together into a single fraction. So we just do this in reverse, and here's the great thing about it. The one big fraction has a plus sign and a minus sign in the numerator, and that prevented any cancellations. Well, now, where are the plus and minus signs located? They aren't inside the fraction, they're between the fractions, and so in each of the fractions, like in this first fraction, 12a to the second b to the fourth divided by 15ab cubed, what you have are all multiplications. These are all factors, so now you can cancel things, right? So now that the plus and minus signs are not in the fractions, in each of the separate fractions, you have factors, and we'll do some cancellations. So what's highlighted in red now at the top, after all the canceling, I won't go through the details here, you'll have 4ab over 5, then plus the next fraction will be a to the fourth over 5, minus finally the third fraction will be 2ab to the sixth over 5.